right, so we have delta psi is equal to 8.314 joules per mole Kelvin times 298 Kelvin over 96485, and the units on Faraday's constant are joules per mole volt. All right, and now this is going to be times the natural log of this big old part here. So let's move over. All right, so we're going to start off with our cation concentration. So we have 5 times 10 to the negative, sorry, I don't have that table in front of me. Let me pull it up in the textbook for just a second. All right, so cation concentrations, 5 times 10 to the negative 7. This is potassium here. All right, times its concentration outside, which is 0.004 molar. All right, we're going to add to that the permeability coefficient for sodium, which is 5 times 10 to the negative 9, times its concentration outside the cell, which is 0.145 molar. All right, and we're going to add to this now the anion concentration, permeability coefficient of chloride, 1 times e to the negative 8, times its concentration inside the cell, which is now times 0.004 molar. All right. Now we have all of that over now. All right, the concentration of our cations inside the cell. So times our permeability coefficient, so 5e negative 7 times the concentration of 0.139 molar, right, plus for sodium, we have 5e negative 9 times the concentration of sodium inside the cell, which is 0.012 molar, plus now the concentration of chloride outside the cell, so we have 1e negative 8 times the concentration outside the cell, which is 0.116 molar. All right, so if we go through and calculate all of this, we are then going to end up with our membrane potential, delta psi. All right, so I'm going to calculate the part inside of here first. Bear with me, I have not done this yet, so it might take me just a minute. 5e negative 7 times 0.004 plus 5e negative 9 times 0.145 plus 1e negative 8 times 0.004. Right. So the numerator here is 2.765 times 10 to the negative 9. All right, the bottom part, work on that. 5e negative 7 times 0.139 plus 5e 5e negative 7s, and then all this 5e negative 9. All right, sorry, times 0.012 plus 1 times 10 to the negative 8th times 0.116. All right, and the bottom here, we end up with 7.072 times 10 to the minus 8th. All right, so this whole part here then, if we scroll down, it's going to end up being 0.039099785. All right, and we're going to take the natural log of this. Natural log of that is negative 3.242. All right, and we have to now multiply this by those coefficients at the top. So this whole part now is being multiplied by our 8.314 times 298 over 96485. So and the answer I'm ending up with here is negative 0.083 volts. 832, I'll put the 2 on there. So that's our membrane potential now, negative 83.2 millivolts. All right, so now we're ready to work with our chemical potential formula. So we have the delta G is equal to RT times our natural log, sorry, looks like LH, ln of our sodium concentration now, which is outside of the membrane versus inside, or sorry, inside versus out. So right, Na plus inside versus Na plus outside, right, plus Z times Faraday's times our delta psi. All right, so let's start plugging in stuff in here. And so we have 8.314 joules per mole Kelvin, all right, times 298 Kelvin times the natural log of our sodium concentrations. I keep changing the page of my textbook here. Sodium concentration inside the cell is 0.012 molar. Outside the cell is 0.145 molar. All right, plus now Z is 1. Faraday's 96485, and the units, we have to be careful of the units here, are going to be joules per mole volt. And our delta psi, which we just figured out, so I need to go back just a little bit, is negative 0.0832 volts. All right, so we can go through and start calculating this now. So this whole part of the equation here, natural log of 0.012 divided by 0.145, it's going to, this part here is going to give us negative 2.492 times 298 times 8.314. So this whole part here is going to be negative 6,174 joules per mole, basically. All right, now for this part over here, we can just simply multiply those together, 96485. And 96485 times 0.0832. And we put the negative sign on there because negative, and so this is going to be negative 8,028 joules per mole. All right, and so basically if we add these two together, we're going to end up now with our answer of negative 14,200 joules per mole. And that is our final answer for question number 2.